Hello everyone, welcome back to MAC1105. In this video, I'm going to show you how to solve system of nonlinear equation. In intermediate algebra course, you guys already learned how to solve system of linear equation. The system of linear equation contain two equations. That's what we learned in intermediate algebra, and both of the equation is in linear form, which is in the form of ax plus by equals c. However, for a system of nonlinear, when we mention nonlinear, we mean that one of the equation could be something different from ax squared plus bx equals c. Okay, the degree is higher than the first degree. Okay, so let's see how we're gonna solve that system. Okay, so let's get started. Alright, so I'm gonna put topic today, system of nonlinear equation. So as long as one of the equation in the system is not in the form ax plus by equals c, or is not in the form of first degree polynomial, okay, or is not in the form of y equal to mx plus b, we can call that system nonlinear. Of course, if both of them is not if both of them is not in the form of ax plus by plus c, then yes, it is nonlinear. However, if one of them is nonlinear, we can call that system nonlinear. Okay, if one of the equations is nonlinear, then we can call that system is nonlinear. All right. So how are we going to solve that? And in intermediate algebra course, when you solve system of linear equation, you use substitution and elimination method. Right? For the system of nonlinear, you're going to do the same. Of course, one method will be sometimes could be easier than the other method, depends on the problem, so you guys have to be flexible. You can also grab and get the intersection point between two equations. You can do that one. So totally we have three different way of solving the system, but the graphing method is I'm not gonna do in this video, because we require to have a very good calculator TI-84. So I cannot demonstrate it, and we don't have it. So in this video, I just focus on two methods: the elimination method and the substitution method. Okay, so let's get started. So I'm gonna do the first method first, which is the elimination method. Okay. All right. So when you solve system of linear equation, in order to eliminate it, right? So in order to eliminate one of the term in the first equation and the second equation must be the same. And if it's the same, you can subtract them, or if it's the opposite, you can add them together. And if it's not the same and opposite, we have to multiply the top and the bottom by something so that it's the same, and then you add it, you eliminate one of the variable x or y. Right, so that's what we used to do in intermediate algebra for when you solve a system of linear equation. But for the nonlinear, I think we're going to do the same thing. Okay, for example, we have a system like this. Okay, I have a system like this. I have 2x squared plus y squared equals 17, and over here I have x squared plus 2y squared equal 22. And all right, what do you see over here? You see that the first equation is nonlinear, the second equation is also nonlinear, so both of them is nonlinear. So that's good. I mean, because the condition for a system to be called nonlinear is you just need to have one of the equation nonlinear. However, both of the equation over here nonlinear, then of course this system is nonlinear. So how we're gonna eliminate it? So depending on which variable you want to eliminate. So maybe over here you see that it's not the same, right? And first of all, I want to eliminate the x, right? In order to eliminate the x, you need to have it the same and opposite. So what I'm doing, I'm just go ahead and multiply the second equation by -2. Okay, I multiply by -2. So when I multiply by -2, my system become 2x squared plus y squared equals 17. I'm going to use different color to demonstrate it. Okay, for the second equation over here, so you have multiplied by -2, so you have -2x squared, right? Negative 4y squared equal -44. Alright, so you see the coefficient in front of the variable x is the same and opposite, so we can go ahead and add them up. And when you add them up, what you have negative, right? You have negative 3y squared equal to you add them up over here, give you 30. I believe it is also give you -27, right? Let me see. Yes, -27. Yes. Now you're gonna get the y, so you're gonna divide both sides by 27. Divide both sides by 3, so give you 9. And you take square root, and remember when you take square root, give you plus minus 3. Okay. Plus minus 3. So you have two value for y. It means that we have two value for x. So you're gonna plug into one of them. I think I'm gonna plug into, it doesn't matter which you can put into this one right here. It's easier to do, right? So I'm gonna plug 3 into that. So we have 3 square equal 22, and so I have x squared equal 18 equal 22. So x squared equal 4, and x equal to plus minus 2. Now if you go ahead and plug -3 in, it's going to give you the same thing, right? Because -3 squared give you also 9 times 2 is also 18. So the answer actually the same, plus minus 2. So what will be the solution? What is the intersection point over here? The first intersection point will be okay, so answer. I think I'm gonna put solution. So solution. Okay, so the first point will be 2. Will be 2. 2 and -3, right? 2 and -3. And the other one will be -2 and 3. Okay. What else? We also have more, right? We also have -3 and sorry. We also have 2 and -3. 2, -3, and -2, -3. All right. So you see that we have 4 points. It means that they are these two curves right here. They intersecting at 4 different positions. You know, remember when you do a system of linear, right? When you have two lines cutting each other, we have only 1 point. 1 point as the solution. But for the non-linear system, that's the difference between non-linear system and linear system. The solution could be more than 1. In this case, there are 4 of them because just imagine we have 2 curves right here, and it's gonna overlap in each other at only 4 points. Okay, they're cutting each other at 4 points. They're intersecting each other at 4 points. Okay, not just 1 point, because it's not a line anymore. It's not a line. This is not a line, and if it is not a line, just imagine you're gonna have it overlapping. The curve is overlapping. Okay, and I don't want to mention what the shape of the curve look like, because this is one of the concepts we're supposed to know in pre-calculus. However, if you have graphing calculator, you graph it and you will see it's overlapping at 4 different positions right here. So that is how you see how you do elimination method. I mean, you do the same way as you do for what you do for a system of linear. You mean the process is not the same. All right, how about this example number 2? I have how about this? I have x squared plus 4y squared equal 4, and x squared minus y squared equal 9. So if you look at this one, you see that over here, I can go ahead and multiply this one by -1. Then what we have will be x squared plus 4y squared equal 4, and we get a new equation by multiplying -1. So you have negative x squared because you want to use that opposite and the same, right? Plus y squared equal -9. And what do we have over here? What do we have over here when we add them up? Which is give you 5y squared equal -5. So y squared equal -1. So y is equal plus minus I, right? Alright, what is going on over here? If you have something with complex number, okay, which is not real because it's complex, it's imaginary, then on the graph you don't have the intersection point. So in this case, the system is inconsistent system. Okay, this is inconsistent system. Okay, meaning no solution. Okay, in other words, no solution for this. No real solution. Okay, so it could be like that. There could be no solution. All right. Let's see. What else can we do here? Okay. In my opinion, believe me, for the system of nonlinear, I barely use elimination method. I mean, I can, but I'm not just. I barely use it. I just don't do it. Why? Because I feel comfortable with the other method, which is substitution. I'm going to show you how to do it right now. But if you feel comfortable with elimination, just go ahead. I mean, it still depends on some the problem, right? It still depends on the problem. I can give you something like this. Example 3. What if I have a system like this? I have y equal to negative x squared plus 6x minus 7, and over here will be y equal to x squared minus 10x plus 23. Okay, this is not linear, right? Because you recognize this is parabola, and you see this is opposite and the same, right? If I go ahead and add them up, eliminate it, so I add them up, we just give you what 2y equal to this cancel. This you add them up, give you negative 4x, right? Equal what? Equal 20. Okay. So what is going on over here? What is going on over here? If you eliminate like this, right? Even though that is the same and opposite, you see that if you eliminate it right this, your equation is in terms of two variables, x and y. Okay, which is in my opinion is not good. So this is how I recommend you to do. So instead of eliminate the x over here, okay, so this is okay. It still works, but it's just harder. I think I'm gonna multiply. I multiply over here by -1, and when I multiply by -1 here, so my equation on the top will be, you keep it, but the equation at the bottom, I use different color, could be -y equal -x squared plus 10x minus 27, and when I add them up, the y is gone. So all you have left is the x. Alright, all you have left is the x. Okay, so we just give you minus 34. You see, all you have left is the x. You can solve for this one. Okay, you can solve for this one. So you just remove it to the other side. Now I simplify it, give you x, and this is give you 17, right? Equal to 0, right? Did I calculate something wrong over here? Let me check. Oh yeah, right here I got something wrong. I copied them wrong. This is not 27. It's 23. That's why. It's 23, and that's why over here is 30. So if it is 30, then over here 30, and then over here 15. Alright, and now you see that you can go ahead and factor them. So we have x minus 3, x minus 5 equal to 0. So over here I can apply the zero product property, and x equal 3 and x equal 5. And now you can go ahead and plug them in. Plug in here to get the y. Okay, plug in here to get a y. So I plug 3 over there, so you have a y equal to negative 3 squared. 6 times 3 is 7, which is negative 9. 18 minus 7, which is 2. And over here you plug 5 over there, give you negative 5 squared. 6 times 5, 7. 25. 30 minus 7, minus 2. Alright, so you have 2 points. So the solution will be 3, 2 and 5, negative 2. So we have two intersection points. Now you see that for this one it worked, but you gotta do one more step, which is you have to use substitution in this case. And you see, because we do an elimination method, now we have not learned substitution. So you can, but because you use the concept, you already learned intermediate. But this is not the best way, right? So you have to be flexible. And for this one, I eliminate, I give you I show x right away. But this one where I eliminate the x, I still get stuck with the x. So you have to be flexible when you eliminate it. It means that there's no more. For example, if you eliminate x, there's no more x. You eliminate y, no more y. If I just eliminate this, we still have x and y, which is not the best method, not the best approach. So that's why I eliminate the y, and we can solve for x. Okay. Okay. Let's see what else. All right. How about this one? Example number 4 right here. So I have a system like this. This system is interesting. Also only have negative 3 over x. So I have a rational expression over here, 1 over y squared equal 13, and over here I have 5 over x squared minus 1 over y squared equal negative 5. All right. So what is going on over here? So if you notice, you see that over here, right? They're the same and opposite. I can add them up. So if I add them up, what I have? The y will be gone, right? So what I have left is negative 3 over x squared, right? You add it to 5 over x squared. And the y is gone. 1 over y squared plus minus 1 over y squared is gone. So on the right hand side, I add them up. Give you 8, right? 13 minus 5 is 8. And now what happened? When you add them up, there's only one variable left, and you can solve for this. Equal 8. Then you have x squared equal 1 over 4, which is x equal plus minus a half. So you have two x. And now you're gonna go back in and plug into one of the equation. So you have I'm going to plug into the first one, so you're going to have negative 3. Okay. 1 over 2 square right? Plus 1 over y squared equal 13. Alright, so we're gonna solve for y. Okay, so I have 13 plus 3 over 1 over 4, which is 13 plus 12, which is 25. So your y squared will be equal to 1 over 25, which is y equal to plus minus 1 over 5. Okay, so you have two answers over here already. You have two answers over here. Solution. The first one will be a half and 1 5 and a half and negative 1 5. That's the first two one. Now, but that is just when we replace 1 half. What if I want to replace negative 1 half? So if you replace negative 1 half, which just give you the same thing, right? Negative 1 half plus 1 over y squared equal 13. So which is equal to 1 over y squared equal to 13 plus 3 over 1 over 4, right? Which is also 25. So over here y is also plus minus 1 5. So what is going on? We have another just the other solution, the other two, which is negative 1 over 2 1 5 and negative 1 over 2 negative 1 5. Alright, so totally for this problem we have 4 intersection point, 4 solution. Okay. Okay, the second method of solving the system of nonlinear, of course, it is substitution method. Okay, substitution. And this is my favorite method. I mean, because for substitution method, it works all the time, you know. And you don't have to. The good thing is that you don't have to find and determine which variable you want to eliminate. All you have to do is you're gonna solve one variable in terms of the other one. You pick one equation, the one that's more convenient, the one you feel comfortable. You pick that one. You solve one variable in terms of the other variable. Then you plug them back. That's what is the substitution method for. Okay. For example, I have a system like this. And most of the time when you use substitution method, you use for the system that contain only one nonlinear, the other one is linear. Okay, for example, in this one you see that I have the first equation over here is nonlinear because I have a second degree, but the second equation I have linear. So when you have one linear and the other one is nonlinear, you should use substitution. Actually, I mean, in this case, I mean, there's no way you can eliminate anything. You have to, you know, you must. It's obligation here. There's no way you can do anything to eliminate it. So you have to use substitution in this case. And of course, the second equation is just linear. It's easier to manipulate. So I'm gonna pick this one to start. Okay, and then I'm gonna solve x in terms of y, right? So literal equation, you solve x in terms of y. So you're gonna have 50 minus 7y. Okay, all right, you solve x in terms of y, so everybody know how to do this already. Then I'm gonna plug this in here into the first one. So if I go ahead and draw this, you can see that I'm gonna plug this one into this. All right, then my equation become what? My equation become 50 minus 7y squared, right? Plus y squared equal to 100. There you go. And now we have to expand this one out. I mean, to some student, okay. Substitution is hard, but to me, I mean, it's easier. It's up to you. You can use anything you want, but I mean, that's what I already told you. Like, if you have one equation non-linear, the other one is linear, you should use substitution. Alright, go ahead, expand it, which is give you 2500. 700y and plus 49y square plus y square equal 100. Okay. So have 50y square minus 700y plus 2400 equal to 0. And you divide both sides by 50, you have y square minus 14y plus this divided by 50, which is give you 48. Yes. Alright. You divide both sides by 50. Okay, so you have a quadratic. Now you can go ahead and factor them. 48 is 16 with 6 times 8. Alright, so we y minus 6, y minus 8 equal to 0. And here you go, you can solve for y. Okay, solve for y. So y equals 6 and y equals 8. Now go ahead and plug into this to solve for x. Plug it over here, okay? So let me use differential. I'll plug this one in here. Alright, we're going to solve for x. So you have x equal 50 minus 7 times 6. X equal to 50 minus 7 times 6, which is 7 times 8, which 50 minus 42, which is 8. 50 minus 56 would be negative 6. Alright, so you have two solution. 2 1 will be, the first one will be 8 6, and the other one will be negative 6 8. Okay, that's how you do substitution. Of course, I mean some problem is you must use substitution method because there's no the other way. For example, for this one right here, I have a system. I have a x minus 5 square and plus y square here equal to 25. Over here you have square root x minus 8. Whether or not this one we can use elimination, I mean we can, but for example over here I go ahead and square both sides. You see the square over here I cancel out, but if you do like that, I mean it probably take more time, right? So you have to be flexible, okay? You gotta be flexible. So in this one I'm gonna go ahead and put y, and you're gonna plug y over here. Okay, you're gonna plug y over there. Then my equation become what? My equation become my first equation become x minus 5 square plus, right, you're gonna have 3 square root of x minus 8 totally square, right, because the square for the y is still there, equal 25. Here you go. Now you have x squared minus 10x plus 25. You square this one, you can go ahead and throw the radicals here. You have 9x minus 8 equal 25. And you keep expanding out, distribute it, which is give you 9h 72 minus 25 equal to 0. So you have x squared minus x, 25 is gone, minus 72 equal to 0. And this one you can factor them out because 9 times 8 is 72. So you have negative 9 plus 8 equals 0. Then you got 2x, right? X equal 9 and x equal negative 8. Now we're gonna go ahead and plug into the first equation. The second equation, which is, so we're gonna have y plug into the second equation. You have 9 minus 8, which is 3. Okay, and over here you have y equal 3 negative 8. Negative 8, which is give you what? Give you negative 64, right? Which is 24i. Not good. So this, you see the answer over here is not good. Okay, the answer is not good. It mean what? It means that we have only one answer, one solution. So solution over here. Solution over here will be 9 and 3. There you go. Alright. I mean you just need to be flexible, okay? Alright, let's see. We can do anything else here. Alright, there's some problem. Is very interesting, you know. Let's see. Example number, I don't know what example now. This one 2, so this one must be 3. Let's see. I try to find something special. Okay, how about this one right here? Okay. X squared over 4 plus y squared equal 1. X equal -2 y squared plus 2. Okay, I'm trying to do substitution here. Okay. So if just think about it, if I use the second equation, right, and I plug this one in here, and you square it, which is give you the 4th degree. Just imagine if I do substitution like this. If I take this, I plug it in here, right? Okay, then my equation become what? Become -2y squared plus 2 totally squared over 4 plus y squared equal 1. Let's think about it. You don't want to expand this one because this will give you the 4th degree. You don't want to deal with that. So if I do substitution like this by picking the second equation, which is not good in my opinion, so I think I'm gonna pick the first equation and I'm gonna solve for y squared. So solve for y squared, so you have 1 minus x squared over 4. Alright, then you're gonna pick this one and you plug over here. Let's see what happens, if it is easy or not, or will be the same thing. Oh crap, it's also give you the 4th degree. It's also give you the 4th degree. So I think in this one we have to use the elimination. Yeah, which is easier. Elimination is easier. So that's why I mean you gotta be flexible. So this one, if you do substitution, it's be. I mean we can do it, but it's just hard to do. I mean because you don't want to deal with the 4th degree. So I think you gotta do elimination for this. Okay, substitution is not nice. Okay, we can, but I mean it's not gonna work. Okay, I mean I don't mean it's not gonna work. Like it take more time. I mean, and you guys don't know how to solve system of 4. Yeah, I think it's better to do elimination over here. So substitution is not working in this case. Okay, elimination is much better. So you see that no matter what, I pick the first equation to start with or the second equation to do this to start with substitution, it's not good. So I gotta do elimination. So how we do elimination over here? Just imagine. Now let me use different color to do this one, okay? Because right now we gotta do elimination and substitution and give you something hard. So I think I'm gonna use this color. Now I'm gonna keep this one. Okay. Then I'm gonna move this to the other side, which is plus 2y squared equal 2. So add both sides by 2y squared. Now I'm gonna multiply. Okay, I multiply the first equation by -2. Then my new equation will become my new equation will become what? Will become multiplied by -2, which is negative x squared over 2 minus 2y squared equal -2. And for the second one, we keep it. And what we see? You see the blue and the green over here, the opposite and the same. You can go ahead and add them up. It's gonna cancel out. So when you go ahead and add them up, which is give you negative x squared over 2 plus x equals 0. Equal negative 2 plus 2 is 0. So what I have right now is negative x by LCD plus 2x equal to 0. And this is equivalent to x squared minus 2x equal to 0. And now you can factor them out. See that? Okay, you factor them out. Sorry, I have something like that. Okay, equal to 0. And this one x equal to 0. X equal x minus 2 equal to 0, which is x equal to 2. Okay, and now you see that we can solve for y. Yeah, you're gonna plug in plug over here. Okay, so you have y squared equal to 1 minus 0 square over 4, which is equal 1. So y equal to plus minus 1. And okay, y square equal to 1 minus 2 square over 4, which is give you 1 minus 2 square is 4 over 4, which is 0. So y equals 0. So how many answer we have here? Solution. My first answer will be 0, 1, and 0 minus 1. Okay. Then the second answer will be the second one, and the third one will be 2, 0. There you go. So totally we have three solutions like that. Okay. Yep. So you have see, I mean, you have to be you have to be flexible. You know, you gotta pick wisely which one work, which one is not working. If it is work, then it's easy for you. If it's not working, then you gotta switch this. You gotta switch gear. You gotta do a different way. You know what I mean? Yeah. Okay. Good now. Okay. So I think I'm gonna stop right here because the strategy is just like that, but you have to pick wisely what method you're doing. I mean, you have to practice a lot to get used to it because each problem has different approach. Depends on the problem, so you have to practice. Okay. I mean, as long as you practice, you should be okay. It's not really that bad. And you can use, I mean, sometimes the question asks you to solve the system. You can use any method you want. You don't have to use elimination, or you don't have to use substitution. It just depends on you, okay? Alright, so I think I'm going to stop here. And if you have any concern, please let me know, okay? So I will be seeing you next time in the next video. Bye-bye.